Today we're going to go over how to find the inverse of functions. Here is an equation for finding the inverse of a simple function. And here is a graph for where they show the inverse of a function, as well as here. Here's a parabola that has been reflected over the line y equals x. And here's another reflection of a function over y equals x. Here are a few video clips to show you just how to find the inverse of functions.
Then we're going to write the function f inverse by interchanging the x and y. Next we'll solve for y, and then we'll go back and replace y with f inverse of x. Okay, so let's do an example. So let's say we have f of x equals 3x minus 4. Our first step is to say, well, f I'm going to write as y equals 3x minus 4. In other words, I'm replacing this f of x with a letter y. So this is still the function f written using an x and a y. All right, now we want to find f inverse. Okay, so how do we find f inverse? We want to keep track of what we're doing. We switch. Everywhere we see a y, we write an x, and everywhere we see an x, we write a y. So these are not the same functions. This is the function f, and this is the function f inverse. We want to keep track of that. Now we need to solve for y. Okay, what I'm going to do to solve for y, since it's positive over here, the 3y minus 4, I'm going to write this as 3y minus 4 equals x. Everybody hopefully agrees that's exactly the same equation. And now to solve for y, what do? We add 4 to both sides. So I have x plus 4. And then we could divide everything by 3. And notice that'll give you y equals x plus 4 over 3. So on the next step, I'm going to replace the y with f inverse of x. So I'm going to write this as f inverse of x equals x plus 4 over 3. Now, there's more than one way to write x plus 4 over 3. You could write this, it's really a line. You can write this as x over 3 plus 4/3, for instance. But this is fine to leave it this way. But just recall that you can write lines in different forms, like y equals mx plus b. So this is the inverse function, f inverse of x, When? We're going to replace f of x with y, interchange x and y, solve for y, and then replace y with f inverse of x. Let's do an example. So I said, what if you had this function f of x equals 3x minus 4. Now, you could find some ordered pairs on this line, but of course there's infinitely many, so you simply can't list all the ordered pairs on for this function or all the ordered pairs on the inverse. So we want to find an equation for f inverse of x. So this is f of x. So here's our steps. I'm going to call this f, and I'm going to start out by replacing f of x with y. So I'm keeping track. F is just 3x minus y equals 3x minus 4.
We know it's going to go rise 3 over 1. Rise 3 over 1. And so the graph is going to look something like this. Now, if we were going to look at the inverse, I know this next point. The next point is going to be 3, 1. Okay. 4, 5, 6, 6, comma 2. Now, if I was going to look at the inverse without actually finding the inverse algebraically, if I was just going to look at a graph, what I would notice is the inverse is going to be the exact opposite on the x-axis. So it would be 1, 4, 5, 6, up 2. So the inverse would actually be following this line as this.
Every storm runs out of rain, just like every dark night turns into day.